We are going to talk about making inferences from a random sample. So this is TEK 7.12b. Okay, so go ahead and write your name on here as well, and then today's date. Okay, so we are making inferences from some kind of sample that we're given. So that's coming to some kind of conclusion. What you know, and then what you need to know, and we are going to make predictions. So let's go ahead and read the first part. A shipment to a warehouse consists of 3,500 MP3 players. The manager chooses a random sample of 50 MP3 players and finds that 3 are defective. How many MP3 players in the shipment are likely to be defective? So in order to solve this, we look at the important stuff. So it says the shipment is a total of 3,500. But he's taking a random sample to find out approximately how many are going to be defective for the whole shipment. So his random sample consisted of a sample total of 50, and 3 are defective. So we are going to find out how many are likely to be defective. So we are going to set up a proportion. So we are going to do the sample on the first fraction. So sample, and then a total on the second fraction. So in this proportion, how many in the sample are defective? There are 3. So we're going to put defective over the total. So 3 out of 50 are defective. And we want to find out how many are defective in a total of 3,500. So we don't know how many are defective. So that's going to be our X out of our total of 3,500. So once you have your proportion set up, we are going to play pool, solve the proportion. If you want to, you can look for that common number, or a 5 times what gets 3,500, and then do the same thing on the 3. But this way will always work, so I'm going to show this way. We are going to play pool, cross multiply. So x times 50 is 50x equals, we are going to multiply the 3 times the 3,500. So in order to multiply this, we can just leave those 2 zeros off and then add them back. So I'm going to do 35 times 3. What is 5 times 3? It's 15. What is 3 times 3? 9, 10. But then we need to put those 2 zeros on there. So it's 10,500. And then we are going to have to divide by whatever number's in front of the 50. So divide by 50. Divide by 50. So in order to make it a little easier, we are going to cross out common zeros. And now we're doing 1,050 divided by 5. So 1,050 divided by 5. Make sure you're paying attention, Adriana and Ernesto. 5 goes into 1, 0. 5 goes into 10. 2 times, that's 10, so it's even. Carry down a 5. 5 goes into 5 one time. 1 times 5, 0. Carry down 0. So 5 goes into 0, 0 times. So that means there will be 210. X is 210. But we need to make sure that's what we're actually looking for. So it says how many MP3 players in the shipment are likely to be defective. 210 are likely to be defective. Does that make sense in our fractions? So based on the sample, you can predict that 210 MP3 players in the shipment would be defective out of that 3,500. Okay, so let's keep on going. Keep up the good work, Noe. Keep up the good work, Zachary. Rose asked students in the lunch line how many books they had in their backpacks. She recorded the data on the list. Make a dot plot for the books carried by the sample of students. Okay, so we have a 2, so we're going to put a dot on 2. We have a 6. We have a 1. We have a 0. We have a 4. We have a 1. We have a 4. We have a 2. We have a 2. Okay, so from the data that they've given us, we've plotted on our dot plot. And we are going to make inferences based on that data. So most students have blank books, blank 1 books in their backpack. Oh, maybe not books, sorry. I shouldn't have put that there. Most students have blank 1 book in their backpack. So if we look at 1, is it more than 1 book, at least 1 book, or less than 1 book? It's not less. Most students don't have less. They have more, but aren't there a few that have 1? So the word we'll use here is at least. At least 1 book in their backpacks. Most have fewer than blank books in their backpacks. So fewer than what? Fewer than 6? But this says most. Most means majority. So each one of these say most, majority. Most have fewer than, well, all of them have fewer than 6, but where do most of them have fewer? Fewer than 5. Because it would be fewer than 4 because it includes 4. So we're saying fewer than 5 books in their backpacks. Then most students have between what? What 2 numbers can we say that most books are? Between 1 and 4 books. That's where the majority of the dots lie. So between 1 and 4. Most students have between 1 and 4 books in their backpacks. Okay, so let's move on to box plots. The number of pets owned by a random sample of students at Park Middle School is shown below. Use the data to make a box plot. Okay, so we need to first list the data out, and then we can find the median, the mode, the range, and all the quartiles. So let's put these in order. So 0, a 2, 2, 3, 4, 5, 6, and 9. So we need to know the range. So this is our minimum. This is our maximum. Then we need our median. So let's count until we get to the middle. So 1, 2, 3, 4. So this is our median. Okay, and then we need our first lower quartile and our upper quartile. So we look here, so we count down. So this is our lower quartile. And so we do the same thing here. This is our upper quartile. So now that we have all of our numbers represented, now we can put it on the number line. So the min is a circle on 0. The max is a circle on the 9. And then we do lines on the lower quartile, median, and upper quartile. So lower quartile, so 1. or a 2. The median is 3. And the upper quartile is 5. So we make the box. That's your box, and here's your whisker. So what this tells us is that they are mostly in this bigger rectangle. So we need to answer these questions. So a good measure for most likely number of pets is most. Remember most? Most likely. In a box plot, that is considered your median.
Who are you talking to?
I'm talking to the video. I'm talking to my students.
Oh, Mommy.
You need to go, okay? Go.
Aiden spanked me.
Okay, well, sit down there on the ground and be quiet.
Hi.
Okay. Number of pets is 3. Because 3 is the median. Blank of the students have between blank and blank pets. So %, because this is, remember how we talked about this is 1/4, this is 1/4, this is 1/4, this is 1/4. So we are going to look at 1/4 and 1/4 make 50%. So 50%, and if you don't remember this, this is in the blue notes. So 50% lies in here. %, of the students have between we can either look at 0 to 3 pets, 2 to 5, 3 to 9. So it looks like 0 to 3. At most, every student in Parkview has at least, so it says every student at Parkview has at least, almost, so it says almost. So we have one student, remember this data, has that min, which is 0. So almost, every student in Parkview has at least 1 pet. Okay, so this is using the different charts and graphs to make inferences. I want to send a shout out to Elijah and Elena. Y'all have been working really hard this week. I want y'all to keep up the good work. Also, Fernanda, keep up the good work. See you later.